Our problem is problem set 31, problem 3. And the first part of this problem is why does the man move backwards? There are two ways to justify this. One is using Newton's third law. Newton's third law says that the force of the man rifle system on the bullet is equal to the force of the bullet on the man rifle system. So, using Newton's third law, and assuming that the right direction is forwards and the left direction is backwards, and since the bullet starts from rest, it has to be accelerating towards the right, forwards, which means that the unbalanced force of the man rifle system on the bullet is towards the right. And by Newton's third law, the force of the bullet on the man rifle system must be acting in the opposite direction and has equal magnitude. Since the man is also at rest initially and it accelerates towards the left, it must be moving towards the left. And since we said that left is backwards, the man must be moving backwards. Another way to justify this is using conservation of momentum. Initially, the man rifle and bullet system is at rest, meaning that momentum is zero as velocity is zero. After the bullet is fired, the bullet has positive momentum as its velocity is 500 meters per second towards the right, forwards. And this means, in order to conserve momentum, which was zero, the velocity of the man rifle system must be negative. And that means, since velocity is negative, the man rifle system must be moving towards the left, which is backwards.
B. Calculate the speed at which the man recoils. Now at first you have to draw the momentum bar chart, and since at the start, none of them are moving, so the bullet and the man have zero energy. And there's no external forces.
Zero momentum.
Zero momentum. And then there's no external forces here, because as I mentioned on the problem, you're standing on very slick ice. Force of friction is not affected. And for this one, after it fires, well, the bullet moves and the man moves. We can first use this stuff on bars plus bars to the bars to find out the momentum of the man. So 0 plus 0 is equal to 0. So this one must have a total momentum of 0. And the only way to do that is that the man has the only way to do that is the man has a negative momentum of the mass of the bullet. So you can write this as momentum of man is equal to negative momentum of bullet. And since P is in B, you can write it out as mass of man, velocity of man is equal to negative mass of bullet times velocity of bullet. You want velocity of man, as mentioned in the problem. So velocity of man is equal to negative mass of bullet times velocity of bullet divided by mass of man. The problem already gives all three of these, and all I have to do is just to plug it in. Velocity of man is equal to the mass of bullet is 0.01 kilograms. Velocity of bullet is 500 meters per second. And the mass of man is 70. Simplifying, this will be equal to negative 5 over 70, or negative 1 over 12, which is around negative 0.07 meters per second. But the problem mentions find the speed at which it recoils. So it's not really negative. So the absolute value is negative 0.07 meters per second. So the speed is just simply 0.07 meters per second.